OpenAI have released a new feature called Distillation. It's an addition to their fine-tuning suite, and it allows you to use their stronger models like O1 or GPT-4o to fine-tune weaker but faster or cheaper models like GPT-4o Mini on your specific data. So if you're wondering how fine-tuning differs from distillation or whether it could even be useful for your application, I've made this video for you. I'm going to go through this all in a Colab notebook. I'll put a link to this free notebook in the comments, or rather in the description of the video. What I want to do is explain at a high level how distillation differs from fine-tuning. It's a bit murky because there are a lot of ways in which they're actually kind of the same thing. And then I'm going to go through an example where I actually set up some questions, evaluate performance on a model. Then I will generate some data that we're going to use for distillation. I will go over to OpenAI, I'll run the distillation, and then I will get my distilled or fine-tuned model and I'll run evaluation again. So we'll see all of those steps. And then at the end, I'll talk about some more advanced techniques and can refer you to some other videos if you want to take things to the next level. So here we go. Why would you fine-tune or distill? My answer here varies as we go along. Maybe I would have given a little different answer last year, but there are three main cases. The first is that if you're using OpenAI models, but the models just lack knowledge for your domain, and you have tried doing retrieval methods like retrieval augmented generation or RAG using cosine similarity or BM25, if those methods are still giving bad results, it generally is possible to improve results by using fine-tuning in combination with those methods. So that's reason A. Reason B is OpenAI models are responding in the wrong format. So maybe they have the knowledge, but the format of the answer is not exactly laid out as you want. For example, maybe you want citations at the end, or you want the answer to follow a certain chain of thought. Well, in this case, you should try prompt engineering and see what results you can get. But if the range of questions that are being asked of the language model are too broad and the prompt engineering is too brittle, then fine-tuning can come in and help to cover a wide variety of use cases. The third example is if you have a strong model like GPT-4o or O1 and it's giving great results and you think it's perfect for your application, but you just don't want to pay the cost, or you don't want the high latency because those powerful models are slower. So in that case, you can develop a faster model or a cheaper model by using distillation to fine-tune GPT-4o Mini, which is kind of the cheaper, faster model from OpenAI right now. So how is distillation different than fine-tuning? Let me look at it this way. Let's talk about training first. So there are two stages of training a language model. There's pre-training and then there's fine-tuning. In pre-training, this is what OpenAI specializes in, or Anthropic or Gemini at Google. They use very large amounts of raw or minimally processed data, although it's getting more processed over time because that's helping with the results. But broadly speaking, you use very large trillions of tokens of raw data to train the model. Whereas in fine-tuning or supervised fine-tuning, you're typically training a model that already has the benefit of this raw data, but you're now using curated chat templated data. So it's typically question response format. So that's the difference between pre-training and fine-tuning. And of course, if you are not a large model developer, you are not ever going to do the pre-training phase, but you can do some fine-tuning with relatively small amounts of data, even 10 rows, as we'll see in this example, all the way up to maybe millions of rows. Now, when you're doing training, and this applies to pre-training or to fine-tuning, you can take two approaches. There are probably other approaches, but the principal approach is a database approach where you prepare tons of data and you use that to train the model. And the shortcut approach is the distillation approach. So this is where you say, okay, I want to shortcut all of this data prep because I have a larger, stronger model, and I'm going to use that stronger model in order to kind of quickly train a smaller model. And there are two ways you can achieve that. One is you create a data set using the stronger model, which is what we're going to do today. And the other way is more intricate. You can actually look at the weights of the model and the probability distributions the big model predicts, and you can compare the probability distribution of the big model with the small model and adjust the small model to better match the probability distribution. That's a more granular approach. I'll talk about it later. It's the white box approach. So yeah, this is in fact, I'm not going to talk about it later. I'll talk about it now. In black box distillation, You use a stronger model to generate data. This is exactly what we're going to do here in this notebook. You don't need access to the model weights. You just need to generate some sequences, some outputs, and you take those sentences and you use them as data for fine tuning. And then there's the white box approach, which I cover in a video that's linked here. I'll put it in the description too. And here you have access to the model's inner workings, which we do not have for OpenAI models, but for open source models we do. And you use those models to predict a set of probabilities on a data set. And you take the distribution of probabilities for the strong model and you compare it with the distribution for the weak model for every given token in a sequence. And you reshape the student model's distribution to better match the teacher model. And you do that via back propagation. But that requires access to the model's internals, or at least the probability distributions, which OpenAI and other model providers don't expose. In principle, it gives you a faster way to distill the knowledge than just generating data. But it's not possible, at least unless OpenAI decide to expose a specific distillation endpoint that supports KL divergence, which is the mathematical way that we shift one distribution to match the other. Okay, so for this simple approach to distilling or fine-tuning, I'm going to show you 4 steps, or step 0 to 3. What we're going to do is first evaluate the performance of a strong and a weak model, which will be GPT-4o mini and GPT-4o. That'll be the strong model. Then we'll generate some synthetic data using GPT-4o. Then I'm going to fine-tune using that synthetic data, which has been generated with the strong model or teacher model. This is kind of where I'm distilling the knowledge of the teacher model into the student model. And then I'll run an evaluation to see if that all helped. I'll just note here, I'll come back to it later. There is a more advanced video where I discuss synthetic data generation. It's well over an hour long, maybe an hour and a half. I'll put a link to that in the description below. It includes a lot more detail on how to generate larger synthetic data sets and some more advanced techniques around evaluating performance. So to get started in this notebook, we'll install the OpenAI Python package. And you can see here I've done pip show just to see the version we're working on. And next, I'm going to select a model. So you can see here I've got a teacher model selected. So next, I'm going to load my API key. And there's a nice feature here in Colab whereby you can just put some keys in the secrets. And I've put my OpenAI API key here. I've pasted it in and I've just turned it on. And just using userdata.get, I'm able to run this cell and it's going to import my API key from there. So next I'm going to set up some training questions, and I'm going to ask some questions around the rules of touch rugby, which is a little bit obscure as a sport, so not that well understood by large language models. And I've just generated 10 questions here. I've just come up with them off the top of my head. Actually, I generated some of the last ones with the help of ChatGPT. So for example, how much is a try worth 1 or 5 points in touch rugby? And by the way, it's 5 points in normal rugby, but it's only 1 point in touch rugby. Next, I'm going to generate a response. So here I'm just evaluating the performance. And what I want to do ultimately is evaluate the performance of the strong model. This is the teacher model here. And I want to evaluate the performance of the student model here, which is, student. So I'm going to define a function that will get a response from the OpenAI client chat completions create and function. And I'm going to pass in a system message. You're a sports rule expert. I'm going to pass in the question. I'm going to use a low temperature for getting high precision. And I'm going to use top P of 0.9, which is going to help avoid bad tokens when sampling. So it means that it's only going to consider tokens that sum up to 0.9 to 90% probability. Anything above that, it's going to discard the less likely tokens so that we don't hit those. And then I'll simply evaluate. So let's just run that and we'll get a response from the teacher on this question. And turns out in this case, GPT-4o is good at touch rugby because it thinks a try is worth 1 point. Whereas if we look at the student model, it thinks a try is worth 5 points. So you can see the student model here is weaker on this set of questions. So our goal is now to see if we can train the student model to be as good as the teacher model. One way we can do it is by storing the answers from the strong model to these training questions in OpenAI. And the way we do that is by making a function that looks the exact same as the evaluation function, except it additionally has this store parameter here that I'm going to set true if I want to store. And it has furthermore the ability to pass in metadata. This tags the data for when it's stored so that we can query it. So what I'm going to do is set a dataset tag of touch rugby 6. And I'm going to run this cell here to generate data for each of my 10 questions. So I'm generating data now for GPT-4o. You can see here question 1, question 2, question 3. And if I go over to OpenAI, and it's important, by the way, to be in the same project where you created your API key. Otherwise, you're not going to see the data appear. So go over to OpenAI, click on chat completions, and then you can see all of your completions, or you can search for the ones here. So I've used a key of with the value of touch rugby 6. So I'll apply this, and I should start to see my answers appear. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I refresh, hopefully I'll have 10, which is the minimum needed for fine tuning. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. Okay. And I have noticed sometimes that all of my completions don't appear. So I'm just going to run that again and see if we can get all of them to appear in one go. So let's filter out touch rugby 7, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I have 10. I'm not sure if sometimes some aren't appearing because the lengths of the responses are too long or something, or there's an error. But either way, I've got a data set now of 10, which is the minimum that I need. And I'm going to click on Distill. Now, what does Distill do? It just brings you into the fine-tuning interface. So it is just supervised fine-tuning, but it's using the data set that has just been uploaded. And you can examine any of the samples here. You'll see it's got the question, but it's storing also the answer here. And so if we go to Distill, we can select what model we want to use as student. This is the base model, which is mini. And I'm going to use this selected data set, add a suffix here, touch rugby 6. Now, I would always recommend adding validation data. You'll see that in the more advanced video, and you need to upload a JSON file with some validation data. But for now, it's fine. We'll leave it without that. You know, my favorite seed is 7. And now for hyperparameter configuration, I would just go for the defaults here. It's difficult really to know what the learning rate multiplier means in the same way I would know what it means when I fine tune open source models. Typically, I like fine tuning for 1 epoch on data, but it's going to fine tune for a few epochs. So maybe I'm just wrong about liking to fine tune for 1 epoch to avoid overfitting. Anyway, since I don't have great internal understanding of what's happening in the background, I'm just going to use the defaults and create this training job here. Now the model should start to train, and I'll just give it a few minutes. It's going to decide on the hyperparameters to use, and pretty soon we should have a model back that we're able to test. And the fine-tuning job has succeeded. So we can see here that it's been run for 10 epochs. It was only run for, when I ran on a larger data set, it only ran for 3. So if you give very small data, it'll run for more epochs. And it's hard to know what this learning rate multiplier really means without understanding. Could be a LoRa alpha, could be something else. You can see the training loss is falling. It falls down to nearly 0, which means that we are definitely overfitting the data. Generally, I wouldn't recommend that. That's why I prefer just to fine tune for maybe one epoch. But when I can't control learning rate or schedule, like it's probably doing a cosine schedule, but it's hard to know. It's hard for me really to decide on better sets of parameters here. Nonetheless, we've got that model fine-tuned, so we can grab the name of the model and head back to the notebook. Now we can run evaluation on that fine-tuned model. So we've run the generation, we've run the fine-tuning, and now we're going to evaluate. I'll just copy paste in here the name of my model and run that cell. And you can see it's running. And yeah, now we get the right answer. So we've basically trained with this tiny amount of data how much a try is typically worth. Now, it's not surprising it gets that question exactly right because it's directly from the training set. And because we saw it was overfitted, it makes sense that it would get it right. And this is why in practice, you want to set up an evaluation data set that will have the questions worded in a slightly different way. But my goal was just to show you very simply the steps involved here in data generation, upload, fine-tuning, and evaluation. And so I think this example serves that purpose. Now, if you're trying to get the best results, there are some more techniques you might want to layer on top of this. For that, I recommend the synthetic data generation video that I put out recently. In essence, there's a few key things I do differently. First of all, I set up a pipeline for creating the synthetic data. So I systematically create a diverse range of questions based on uploading documents. For example, I uploaded documents around the rules of touch rugby. I generated a diverse set of questions, and then and those were augmented with background information. So the questions are going to be relevant to my topic. And then I generated accurate answers by using a low sampling temperature with a strong model, and further by filtering out the correct answers. So I only would include the data rows if I deemed them to be correct. And to do that, I had to build an evaluation pipeline for the answers. Actually, that's the same evaluation pipeline I used. It's an automated pipeline for determining the quality of a fine-tune versus the base model. Essentially, I ask the model to generate some answers, and then I create a judging model. So I use another LLM to judge whether an answer is correct based on when I give it the ground truth versus the generated response. So I'm going to very quickly go through an example of distillation for touch rugby rules using the advanced script, and I'll just show you the results so you can see what can be achieved. Basically, I generated a set of around 200 questions, touch rugby synth, so about 193 training rows, and then 22 evaluation rows. And I used this data downloaded in JSON format, which the advanced script also allows you to do. I then uploaded that training data to OpenAI for a fine-tuning job. So when I was creating a job, I just uploaded the JSON file here, and I uploaded the validation data here. And then I took the fine-tuned model to see what kind of performance it had. And with that, I ran evaluations, and I compared a few things. So I compared the quality of responses of GPT-4o mini without fine-tuning, GPT-4o without fine-tuning, and then each of the models with fine-tuning. And I also looked at generating the synthetic data using either GPT-4o mini or using GPT-4o, the stronger model. So out of 22 questions, you can see GPT-4o mini is scoring roughly 8 out of 10. And there's some variance here because I rerun the evaluation 3 times or maybe even 5 times to get a mean absolute deviation. Whereas GPT-4o scores kind of similarly. So even though on that single simple example I showed you, it got the number of points correct for a try, overall GPT-4o is not much stronger than GPT-4o mini when it comes to touch rugby rules. Then I fine-tuned GPT-4o mini, and after fine-tuning, it really helped. It brought me up towards about 17, 18 answers correct. And yeah, basically, it didn't really matter whether I generated the data using GPT-4o mini or GPT-4. And the reason for that is I'm injecting ground truth information from the background documents. So because the model has access when answering to the ground truth documents, basically the quality of the model is not that important. Had I generated synthetic data without providing background documents, then probably this score would be higher because the generated data, well, I'm not sure it would be higher. It probably would be similar anyway, because we can see the base models are actually quite similar when evaluated over a large number of questions. And then last of all, I also fine-tuned GPT-4o on the same data set. I think it was actually on, it would have been on the stronger, what I thought would be stronger data set. And yeah, it achieved better performance. It's kind of within the same range. It's within the error bars of GPT-4o mini, but it maybe looks to be a little bit better. And you'll notice as well, we're getting quite close to getting all of the questions correct, which shows you that if you do fine-tuning, it is possible to get significant improvements in terms of answering performance. And yeah, I think this is important because if you feel like fine-tuning is not going to improve the accuracy, then why would you do it? But at least in this case, and I think quite a few other cases I've done, you can get quite better answers with fine-tuning, and it does make that fine-tuning worthwhile. Just a few general notes before I wrap up. So this is a demo of using distillation with OpenAI. I'll note that they have their own evaluation framework that they are offering. You can check it out under the evaluation section here. And what it allows you to do is upload a set of data. You upload it in JSON format. It's the same format as if you're uploading for fine tuning. And you can then either generate responses that are considered the ground truth. Potentially in the future, you might be able to upload responses yourself. I'm not sure why you can't just upload questions and responses right now. But the idea here is to try and measure the quality of your fine tuning before and afterwards, which is the same thing I did. It allows you to define a few testing criteria, but oddly, again, it doesn't provide a straightforward way to just compare the answers generated to some ground truth set of answers. So I expect that kind of feature will be added soon, which seems kind of crucial if you're going to want to run evaluations. Interestingly, there's this option to share with OpenAI the results of the evals, in which case you don't pay for the evaluations. So I guess you can save some money at the price of submitting your data for training on the model. This is strategically interesting because as a company, if you have a lot of data, then it strikes me that your data is valuable and fine-tuned models with that data will be valuable. And so it's not clear to me it would make a lot of sense to submit for evaluation if you have data that's valuable for your industry. So this is the OpenAI Evals. It's a relatively new feature, but probably over time will make it easier to run evaluations on before and afterwards. One other thing I'll note is that Google has fine-tuning available now. I did mess around with a notebook and it's still in an early clunky stage. There are severe limits on the length of inputs of your data and the length of outputs, and those limits don't match in the documentation versus what I experienced when I was testing within the Colab notebook. So I think it'll be interesting when Gemini expands and allows you to do full fine-tuning over a token context of 1 million tokens. Right now it's only, I think, a few thousand. It's actually unclear. So I'm excited about seeing that in the Gemini model. But for now, it's still early days. Meanwhile, Claude, I don't believe allows for fine-tuning. Maybe that's something that's being planned as well. I think it is a useful lever in addition to being able to do retrieval augmented generation and prompt fine-tuning. So that's it for this quick overview of how to do distillation or fine-tuning. I'll put a link below to the Google Colab notebook I ran through today, and let me know if you have any questions below in the comments. Cheers.